Okay, now, this is going on page 54 when we're done. So we're going to talk about bisectors of triangles. So I want you to think without speaking about what makes something a bisector. So tell me, Leah, what does it mean? Like, what makes something a bisector, or what does it mean to bisect something? Okay, in half, like exactly in half, or just like in two pieces? Exactly in half. So that would give me two what kind of pieces? Congruent. Good. So if you bisect something, you end up with, because the something that we're bisecting is going to be sides or angles or something like that. So we're going to either get two congruent segments or two congruent angles, something like that when you bisect it. Okay, it's not just cutting it into two pieces, but two congruent pieces. Okay, good. All right, so the bisectors give us something. It says blank is a point when blank is when a point is the same distance from two or more objects. So this word that goes here is equi, there's no L there, equidistant. Okay, so the points can be equidistant from the same place, meaning they are the same distance. Equi referring to equal, and then distant referring to distance. See how that works? But even though this equi means equal, there's no L there. It's not equal distant. It's a prefix. Okay, we good? All right, so we have a few theorems. This first one says, this is the perpendicular bisector theorem. So there's two things here. We've talked about bisectors, we've talked about perpendicular, we're putting them together. We've actually already written the equations of those a little bit. But if a point is on the perpendicular bisector of a segment, so if you look at this picture right here, here's my segment, line segment AB, then this line XY is perpendicular to the segment and it cuts it into two congruent pieces, therefore it is the perpendicular bisector. All right, so if you have a perpendicular bisector, okay, so if a point is on the perpendicular bisector, any point on that line XY, okay, then it is equidistant, there's that word again, equidistant from the endpoints of the segment. Okay, so this is all talking about bisecting segments, but in the process, we end up with triangle stuff in there, right? So we're looking at line segment AB and line XY. Well, this point, any point on this perpendicular bisector here, so let's look at point X right there, that point is equidistant from the endpoints, which makes these two pieces here congruent. Okay, so if we actually look at them, all this is really talking about is it being the same distance, but when you look at them and actually think about them as being segments, then those make sides of a triangle, which means that turns it into what kind of triangle? The big one. What kind of triangle is triangle AXB? Triangle AXB. Isosceles. Isosceles is the best you can do. I don't know where you're getting equilateral from because you have no idea if AB is the same length as AX. Because basically I can take this point and I could drag it up and down this line. And if I drag it down here, then that point is still the same distance away from the endpoints, but it doesn't change this at all. So this gives me an isosceles triangle, not an equilateral. Could it be equilateral? Yes, but that's not what this is telling me. So what this applies to our triangles then is if I have an isosceles triangle, and if you draw a segment from the vertex perpendicular to the opposite side, what part of the triangle would this segment right here be? What part of the triangle is that segment? XY. It's what? The height. Okay? So if you have an isosceles triangle and the height is drawn to the base like this, then that height, since height is always perpendicular to the base, is also the bisector of the base of the isosceles triangle, right? And then it takes this isosceles triangle and cuts it into two what? Right triangles. Congruent, they are congruent right triangles, right? Because that isosceles triangle is symmetric. Okay, so the conclusion that we actually draw from this specific theorem is that line segment AX is congruent to line segment XB. Then, because of that, the other thing that we know, like that's the direct descendant of the theorem, but then that also tells us that triangle AXB is isosceles. Okay, everybody okay with that? So if we were explaining in a proof how we know it's isosceles, it's not isosceles because of the perpendicular bisector theorem. It is the perpendicular bisector theorem gives us congruent sides, and then since the sides are congruent, that's what tells us that's isosceles. So it takes a couple steps there. Okay, it's always important to know why you know what you know, right? Not just because that's perpendicular, so it has to be isosceles. It doesn't work that way. It goes through kind of a couple of steps there. All right, so then we have the converse. Remember, the converse just works in the opposite way. So now this says, instead of saying if it's on the perpendicular bisector, then it's equidistant, this says if a point is equidistant from the endpoints of a segment. Right, so what we know here is we've got this segment here. This point X is equidistant from the endpoints. That means it is on the perpendicular bisector of the segment. Now, it does not guarantee, if you see a picture like that, it does not guarantee that that is the perpendicular bisector. What it says is that the point is on the perpendicular bisector, because I could still have this, there's nothing here that tells me that this line is actually perpendicular. You with me on that? Because I could have this, right? Now, is this point right here equidistant from the endpoints of the segment? Yes. And so the line that's drawn in there could be drawn like that, right? So that could be on, it's also on a line that isn't the perpendicular bisector. So all this is telling me is that it's on the perpendicular bisector. For me to actually know that it is the perpendicular bisector, then I have to know a little bit more information. So there's two pieces that go with this. Right? And that is that the length of AY is congruent to the length of YB, because that's from the bisector part of it, right? And then line XY is perpendicular to line segment AB. All right, so you have to know at least one of these. So, if we know that that point is equidistant from the endpoints, like they give us in that picture, then if we also know that it bisects it, then it has to be perpendicular. Or if we also know that it's perpendicular, then it has to bisect it. So basically what these two theorems do is they relate three pieces of information. They relate this being the perpendicular bisector to these being congruent. And you can have any two pieces of any two pieces of that information tells you the third one has to be true. So if these are congruent and this is perpendicular, these are also congruent. Or if these are congruent and this is perpendicular, then these are congruent. Or if these are congruent and these are congruent, then this has to be perpendicular. But basically, you have to have two of the three every single time. Does that make sense to you? Okay, so you have to have two of the three. That's if we kind of put them all together in one thing. We're good? Just being an isosceles triangle with a line going through it doesn't mean anything. It just means that that point's on the perpendicular bisector, but that might not be what you actually have. So you have to be careful assuming things. Okay, we all good so far? You're confused? On what? On nothing? Oh, well, if it's nothing, you're confused? You have a question? Okay. All right, so then we have the angle bisector theorem. So this says if a point is on the bisector of an angle. So when I look at that picture right there, it is labeled that these are congruent, and it tells me that they're congruent, which it wouldn't have to do both. But since they're congruent, then ray PC is the bisector of the angle. Does that make sense? Because when it gets bisected, you get two congruent pieces. So if this point is on the bisector of an angle, so point C is one of the points on the bisector. There's an infinite amount of points on that ray. Could be anywhere. Okay. If that is true, then it is equidistant from the sides of the angle. Does that right there say anything about anything being perpendicular? No, but distance is always measured by a perpendicular distance. So if I want the distance from me to that back wall, okay, there's an infinite number. I could walk to that back wall in any sort of angle, right? And if I walk directly in front of myself like this, then that's going to be the shortest path. If I walk over there to the corner, that's going to be longer, right? So your actual distance from something is always a perpendicular distance. That's why height's always perpendicular, all that kind of stuff, right? Because there's different ways to get there. So if I'm going to actually measure the distance from C to this ray, I could get there a lot of different ways, right? But this is the actual distance because it's perpendicular. Does that make sense to you? So it's nothing about it being a perpendicular bisector or anything, but that's how distance is measured. So since this is an angle bisector, then C is the same distance away from this side of the angle as it is from this side of the angle. If I had a point right here, whatever point that is, it's the same distance away from this side than that side is right there. So what this tells me here then is that the length of AC is equal to the length of CB. Okay? Because it talks about it being equidistant, right? And then if those two lengths are equal, then what do you know about the segments? They're congruent, okay? So line segment AC is also congruent to line segment CB. The theorem talks about same distance, which means our distances are equal. Then the reason, since they're equal, it makes them congruent. That's the definition of congruent segments. Definition of congruent anything gets you from equality to congruence, because you got to jump back and forth between them depending on what you're going to talk about. Okay, we good? All right, so then the converse says, if a point is on the interior of an angle, is equidistant from the sides of the angle, right? So here this point is right now. Here's point C. With what they gave me in this picture, did they tell me that that is an angle bisector? No, they did not, right? They just told me that C is the same distance away from those two sides of the angle, right? And since C is the same distance away from both of them, then it is on the bisector of the angle. So my conclusion then, since C is the same distance away from both sides of the angle, is that that ray is the bisector of the angle. So I can say, come on, it's thinking, it'll move in just a second. There we go. Ah, dang it. All right, so then what I know is ray PC bisects angle APB. That's what I directly get from that. And then since it bisects it, that tells me that angle, can I say angle P is congruent to angle P? No, but I can say angle APC is congruent to angle BPC. Okay, any questions about that? Good? All right, so let's look at how you have to think through these. Remember, you're not going to look at a problem and just automatically start doing work. You have to think about what you know. You have to be able to explain how you know what you know, even if I'm not making you write it down. Because at some point you might have to write it down. You need to be able to do it in a logical fashion. And it can't be, well, because it has to be, because this and this and this. It has to be some sort of rule or logical process that you can talk somebody through. All right, so this says we're going to apply the perpendicular bisector theorem and its converse. All right, so on example 1, we are looking for, we're going to look for the length of BC. Am I leaving the little line segment off of here? Like, should there be a line segment up here? Yes or no? No, because that says find the length of line segment BC. All right, so let's think about what we're told. Okay, this is what we have. They labeled that this is perpendicular, right? What else did they tell us, basically, besides just that it's perpendicular? Is what? How do you know it's isosceles? Okay, awesome. These two have the same measurement on them, so their lengths are equal, which means they're congruent, right? So remember the whole perpendicular bisector thing. There's 3 pieces of information. These sides being congruent, these pieces being congruent, and this being perpendicular. You have to have 2 of the 3. Do we have 2 of the 3? Yes. So then what that tells us, what we were given, from what we can conclude is that this line is the perpendicular bisector, which makes these congruent. Does that make sense to you? So what's the length of BD? 16, right? So to find the length of BC, that is 16 plus 16, which is 32. That is the length of BC. That is the segment addition postulate. Yes, you have to show that work. That shows where it came from, because there's not a 32 on that picture at all. Okay? Process, 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 process. What? No, I'm not going to make you prove it or write it down. You do need to be able to think through it, because at one point you might need to do that. So I would definitely say don't just jump in and start doing stuff. Make sure you know how you know that. Does that make sense to you? We good? All right. So then let's look at this next one. What are we told about this picture? Are we told that it's an isosceles triangle? No. We got two right triangles. Okay, so we're told that PS and SQ are congruent, and RS is perpendicular to PQ, right? So that means RS is what? Perpendicular bisector. So let's just go ahead and write that one down. RS is the perpendicular bisector. Right? So since it's the perpendicular bisector, that means that any point on the perpendicular bisector is equidistant from the endpoints of the segment, which means that these are congruent. So it is an isosceles triangle because that point is the same distance away. That is not something you were directly told. And if you can't separate what you're directly told and what you can figure out from what you have, that's when you're going to start getting stuck on things and trying to assume things when you can't. All right? So we do know that, and there is a good reason for us to know that. So now that these are congruent, solving this is going to be easy. 2n plus 9 equals 7n minus 18. Right? So that gives me 27 equals 5n. Oh, I wrote 25 for some reason. I don't know why. 27 equals 5n. So what does n equal? 27 over 5. Am I done? Nope, you got to plug it back in. So plug it back in to PR. And see what we get. Well, yes and no. I mean, you're looking for PR, so your work, are we looking for PR? Yeah, we're looking for PR, so your work really should reflect that. But they are congruent, so it really doesn't matter in the end. I probably wouldn't choose RQ here just because the numbers are bigger. But PR. All right, so Molly, what'd you get? Huh? Okay, so what did you get after this step? What do you get when you multiply 2 times 27 over 5? How do you multiply fractions, Molly? What do I need to do? Okay. I mean, you just multiply straight across, right? So what's 2 times 27? Okay, 54. So I'd end up with 54 over what? 5 plus 9. So now I got to add fractions. So what do I need? Okay, good. So what would my common denominator be? Aiden, sit up, please. This kind of gives it away. What should my common denominator be? 5. Okay. So I changed that 9 to a what? Something over 5. It's 5 times 9. 45. So do I end up with 10 in the denominator? No. I end up with 5 in the denominator, right? What do I end up with in the numerator, Molly? 99. Okay, can I reduce that? No. Okay, can I reduce that? She seems a little unsure. Nope. Am I done now? Yes, and I am done. Okay. Fractions can't scare you or slow you up, because not only are you going to have fractions on this homework, you're also going to have to factor. And so when you get home and you're having to factor on some of these, you're like, there wasn't an example like this on our notes. You're right, there isn't an example like that on your notes. You know why? Because factoring is stuff that you learned in Algebra 1. So you're going to have to be able to factor and factor correctly, because I've been saying that for like ever. Okay. Applying the angle bisector theorem and its converse. All right, so here we are looking for the length of line segment LM. All right, so here's what we know. They told us that these two angles are congruent, right? And since those two angles are congruent, then KM is what part of this angle? It's the angle bisector, okay? So since KM is definitely the angle bisector, that's what we were given, then any point on this angle bisector is the same distance away from the sides of the angle. So they put that these little segments are congruent. They didn't label that, that they were perpendicular. They didn't label that they are congruent, but they're perpendicular, so you know that that would actually be the distance from that. So since this is the angle bisector, then what has to be true about JM and ML? They're congruent, right? They're the same length. And so then that means that the length of LM is what? 12.8. Okay? Not everything requires a ton of work. It just takes an understanding of what's happening in the picture. All right, so then here, we want to find the measure of angle ABD. ABD, which is this angle right here, given that the measure of angle ABC is 112. So this whole thing here is 112. Now I'm looking for this one. All right, so here's what I know. I have this big angle here, right? And then I have that this right here. They didn't tell me that it's the angle bisector, right? But they did tell me that point D is the same distance away from the sides of the angle. So what has to be true about this ray? It's the angle bisector, right? So if this piece right here has to be congruent to this piece, right? Now, I'm looking for one of them. I don't have any variables there, so I kind of need a variable so I can set something up, okay? So if that's x, right? And then what I know is the whole thing is 112, which means I don't just write down the answer, because you probably already know what it is, because you should, because it's easy, but you have to show process. The angle addition postulate allows you to do x plus x equals 112, which means then that 2x equals 112. What does x equal? 56. Okay. Am I done? Did it ask me for x? No, I made up that letter, right? Well, I didn't make it up, but you know what I mean. So I'm looking for the measure of angle ABD. Is that the measure of angle ABD? Yes, so measure, I don't have to do anything else with the number. So the measure of angle ABD is equal to 56, what? Degrees. Okay, everybody okay with that? Process, process, process. You absolutely have to be able to think and write algebraically. Hugely, hugely important for you. All right, next page. I'm looking for the measure of angle TSU. So what I know here is that I've got this big angle. This point U is the same distance away from the two sides of the angle. So that means that ray SU is what? An angle bisector, which means these two pieces are congruent. So do you have enough to set something up and solve for Z? Yes. Okay. So go ahead and do that and finish up that problem. What does Z equal? 9. Is that all we need? No. I'm looking for the measure of angle TSU. So I got to do 5 times 9 plus 23. It's 5 times 9. 45. And then plus 23 gives me 68 degrees. We good? Good. Measured angle. Good. All right, any questions? All right. So the next one we've already done, but we're doing again because, wow, was this a hot mess on the test. Writing equations of bisectors in the coordinate plane. You have to think, when you're writing an equation, you can't just randomly use whatever's there or whatever you happen to find. You have to think about what you actually need every question you ever do. You need to ask yourself, what do they give me? What does it mean? What do I need? What can I actually find? Okay, all those things have to go through your mind. So we're looking for an equation in point-slope form, and even told me exactly what form to use this time, for the perpendicular bisector of the segment with these endpoints. So I'm going to go ahead and graph it. Negative 1, 6. That's point A. B is at 3, 4. There is my segment. Okay. Am I writing the equation of the line for that line segment? No. I want the perpendicular bisector of that, right? So we are going to just kind of eyeball it because we're not going to guess off of that. But the perpendicular bisector would be something like this, right? That's where the perpendicular bisector would be. What I want is the equation of that green line. I kind of wish I hadn't put the little grid on there now because I'm quite sure that isn't drawn 100% right because we don't know exactly where it's supposed to be. But that's what I'm looking for. So in order to write the equation of the line in point-slope form, which is y minus y1 equals m times x minus x1, I'm very impressed by how many of y'all actually wrote that down before you wrote the equation. That's good. If you are doing that every time, you will know what it is. It won't stress you out because you don't have it memorized, because it's not about memorizing it. That's where some of your bonus points came from. Some of you did very well on your test. You missed most of the bonus points because you're stubborn and you don't write stuff down when I tell you you should write stuff down. All right, so there is that. And then, so the things that I need to write it in point-slope form, I need a point, I need a slope, right? They gave me 2 points. Are either one of those the point I'm going to use to write the equation of that line? No, it is not, okay? What point am I going to use to write the equation of the line? The midpoint. So I'm going to need to find the midpoint, okay? I also need the slope, right? Now, the slope that I find, is that the slope I'm going to use? No, okay? So you got to make sure you're asking yourself those questions as you go through it. So for the midpoint then, I'm going to do, that is x1 plus x2 over 2, y1 plus y2 over 2. Guess what? That was a bonus point too. Even if you missed the whole thing. Some of y'all got bonus points on the bonus one even when you didn't work the problem because you wrote some stuff down that was important for the problem. All right, so then that gives me negative 1 plus 3 over 2, 6 plus 4 over 2. So that's 2 over 2, which is 1, 10 over 2, which is 5. Is this a point I'm going to use to write the equation of my line? Yes. So I'm going to box it so that I use it and not the other stuff. Okay, because that is this point right here, which you can't just pull off your graph even if you happen to hit it when you did that, or you can do it by looking because it's not always going to be graphed for you, and it's not always pretty numbers. So then I've got to find the slope. So slope is delta y over delta x. Oh, guess what? That right there, that was a bonus point too. That is 4 minus 6 over 3 minus a negative 1. So it's going to give me negative 2 over 4, which is negative 1/2. Is that right? That is the slope. Is that the slope I'm going to use? No, that's the only one I was capable of finding, so I found it, and then that helps me with my actual slope. I need the perpendicular slope, which is what? It's 2. It's the negative reciprocal, so it is just 2. These are the 2 things that I am using. Everybody with me? Okay, so now I've got those. I'm using my y minus y1 up there, so it's just y minus 5 equals 2 times x minus 1. Then what? That's it. That's it. Here you don't have an option. That's it. It specifically says point-slope form. On the test, I didn't tell you, except for one of them, so you could have kept going, right? There were more people than I can count on one hand that had an answer right like this, either on the front page or on the back page. But then, again, you're stubborn, and you kept going, and then you got it wrong. Or you kept going, you got it wrong, and then you put that answer or this answer, and I don't do multiple choice grading. Sorry, you weren't the only one. I get that a lot. Like, you can't, you just think there's a couple of different questions. It's one of these two. Well, that's great. You got to pick one. So stop. If it doesn't tell you that it has to be in slope-intercept form, don't do it, because some of y'all are messing it up. And for some of it, it wasn't even the fraction part. I don't even know what the heck some of y'all were doing with them. Okay? So make it easier on yourself. Any questions? All right. The assignment that I'm about to give you, does it go in Schoology? Yes, because it says so on the calendar. You're going to have to factor. Don't come to me and say, I don't know what to do when you haven't even tried, okay? Because I've been telling you and telling you and telling you, you have to know how to factor. I don't care how you do it, as long as you can do it correctly and without a calculator and without cheating. If you got to go to Khan Academy, if you got to do whatever, I even did a math time on that, all right? That is a review. That is Algebra 1 stuff that you absolutely have to do. Because you know what? When I meet with the calculus teachers once a week, you know what their most frustrating thing is? The kids still have trouble factoring. You're going to be factoring for the rest of your mathematical life. In high school and college, you're going to have to be able to factor. You cannot ignore it. Okay? Okay? See? There you go.